everyone, so I'm going to go over about how to write classes in Java. Now we did this a little bit in the previous lecture slides that we did, but we're just going to go over it again, a little bit of review and a little bit of new things in here as well. So classes in Java. Let's remember that a class is just a type in Java. So a class is a special kind of programmer-defined type, and variables can be declared of a class type. This is very similar to what you should have done in classes like algorithms or in data structures where you had to define a particular object or class to contain your particular data. Now, we're just doing this on a much bigger scale in OOP, and we're doing this with some more defined terminology. A value of a class type is called an object, all right? So objects have very specific terminology. It is a value, it is an instance of the class. If A is a class, then the phrase obj is of type A, obj is an object of the class A, and obj is an instance of the class A, all mean the same thing. Now that's really important because these are all different ways that we can talk about how the object itself relates to the class. A class also determines the type of data that an object can contain, as well as the actions that it can perform, meaning that what we write in our class is how our object is going to be able to interact with the rest of the program, or more likely, how the rest of the program is going to interact with that particular object. So what exactly is the difference between primitive types and class type values? Well, a primitive type is a single piece of data, but a class type value or object can have multiple pieces of data as well as actions, which we will call methods. Methods look very similar to functions. They're essentially the same idea. They're the same concept. They're a set of rerunnable commands that we give to a program. However, we call them methods in OOP. So if you ever hear the word function at me, just sub that in with methods because that's really what we're talking about. And the word methods is the terminology that we use in OOP. All objects of a class have the same methods, and all objects of a class have the same pieces of data. It's the same name, the same type, and the same number. For a given object, each piece of data can hold a different value. This is where we get into that is an instance of that class thing. So for a primitive type, we say that an integer x, let's say the variable x, is of type integer. Well, the value of x is 5. And if we have an integer y, then the value of y could be maybe 10. They're both of the same type, but with different values. In the cases of classes and objects, the object could be of a particular class type, such as maybe car, and it could have a particular value for its color, such as red, and a different object, a different instance of that class car, could have a color of green. Now, they're going to have a lot more pieces of data than just one. Realistically, you're probably going to be containing at least 5 or more different data types within your particular class, because the whole point of classes is that we can contain lots of data into a particular object so that we can interact with it and how it relates to each other in ways that make more intuitive sense with how we think about the world compared to just having a bunch of primitive types that we have to keep track of. Now, the contents of a class definition. A class definition specifies the data items and methods that all of its objects will have. And these data items and methods are sometimes called members of the object. So in other words, we have data members and methods that are members of the object or of the class. Data items are also sometimes called fields or instance variables. You'll hear instance variables quite frequently from me, as well as in your book and other sources when you look up how to do things in Java. Instance variables are declarations and method definitions can be placed in any order within the class definition. Like I said before in the previous video, you don't have to worry about whether or not a method comes before or after the one that you're trying to use it in. Java is, or at least it tries to be, smart, and it knows whether or not that method exists, regardless of whether it's placed before or after your use of the method. Now, I do recommend trying to follow some standard practices with how you organize your methods. This is really important just as far as being able to debug your own code and keeping it organized. But again, Java doesn't really care what order you put it in, unlike C++ where the order matters. The next thing that's really important and different about a class type in objects compared to maybe a primitive type and their associated data values is the new operator. So an object of a class is named or declared by a variable of the class type. So we have a class name, let's just call it class name, and we have a class variable, we'll call it class var. And in this case, we have a class somewhere defined as class name. It has some data values in it, and we've decided to create an instance of that, or an object, called class var. The new operator must then be used to create the object to associate it with the variable name. So technically at this point, we haven't actually created an object. So class name, class var with the semicolon, that's not actually creating an object. Instead, we're just reserving a name with space for that associated object. Once we use the new operator, like you can see here, where we have class var equals new class name with open and closed parentheses, then we've actually created that object and allocated the actual memory we need for that object. Basically, what we did before this, just created a pointer that's eventually going to point to an object that you're going to make, but it's not pointing to anything yet. Once we use the new operator, we're actually pointing to an instance of that class. We're actually making an object at that point, and we can actually use that object after we use the new operator. If you try to use the object before the new operator, it's not going to work. It's not going to function. Now, you can shorten this, so most of the time you're not going to write it in two separate statements like this. Instead, you're going to be able to shorten it like so by just kind of smushing those two statements together. You get class name, class var equals new class name, open and close parenthesis. All right. In Java doesn't have any global variables, and this is really important to remember. All of your variables have to belong to a method or a class. So what we saw before was how to create a class object and store it as a variable. Now, you can't have that as a global variable. It's got to exist as some part of a class, which is why it's really important that we remember that we have to have a class that has a main method so we can actually run the program. This is essentially what's going to work as your global workspace instead of just having global variables throughout your Java files. So keep this in mind while you're programming and while you're writing new programs in Java, that we don't have global variables. All of your variables need to be part of a particular class in Java. Next, that's really important is the this parameter. All instance variables are assumed to have the calling object and a dot in front of them. What we mean by that is the name of the object with a dot. So if I had a object named class var like we had in the previous slides, then we're going to have class var dot some method or variable that we're interested in calling. So what really comes down to here is we assume that we already know which object we're talking about, particularly when we're already in that class. Now, what happens if an instance variable has the same name as a past parameter, or if we're not actually in the class that we need to access that data or method from? What do we do? How do we distinguish between two variables of the same name when one is associated with the object and one isn't? And that comes down to the this parameter. So when we say this, we're going to say the one that I have in here, the one that belongs to me. If we don't use this, then we're going to assume that it is the instance variable and not if we don't have this in the statement, in the programming statement that we use, then we're going to assume that you mean the local variable instead of the instance variable. Once you use the keyword this, we assume that it's the instance variable. Instance variable means that it belongs to the class, is the one that you declare outside of your methods in the class that belong to the entirety of the class, and the local variable is the one that belongs to a particular method. So keep that in mind. Using the keyword this is really important for being able to distinguish between an instance variable and a local variable, as well as being able to do this calling object dot syntax that I mentioned earlier. So we're going to go over in the next video how to do some basic programming in Java. We're going to make some loops, we're going to work with some arrays, and I'm just going to do some live coding. At the end of it, the file that I create, I'm going to share with you on iLearn, so don't worry too much if you can't see exactly what I'm doing. You'll have an example of all the code at the end of the video so that you can download it and look at it and see what it looks like.